Hello guys, welcome back. This is the fourth part of SUMO tutorial, which is about the traffic demand generation. In this section, we'll have an introduction about traffic demand in SUMO, review several methods of demand generation, and finally go over the demand-specific modes and their implementations in Netedit. At the end of this video, you'll be able to generate the traffic demand, edit and customize it using the Netedit software. Well, after creating your network topology, you can run it in SUMO GUI, but if you consider no cars appears within it, so we need to define some kind of description about vehicles. In other words, we should define the traffic demand. In the traffic demand, you need to first determine the physical property of demand elements like their type, their lengths, acceleration, deceleration, maximum speed, and stuff like that. By the way, as I mentioned before, SUMO is a multimodal software capable of modeling various types of demand elements like pedestrians, like vehicles, public transportation, or even it allows users to customize their desired mobility type. And second, you should assign routes for each demand elements by specifying their origin and destination points, their route choice dynamics and route choice mechanisms and stuffs like that. You can generate the traffic demand according to two basic definitions, a trip and the route. A trip is a vehicle movement from one place to another defined by the origin point or the starting edge, the destination point or destination edge, and the departure time, while a route is an expanded trip. That means a route definition contains not only the origin and the destination edges, but all the edges the vehicle will pass. So SUMO and SUMO GUI need routes as input for vehicle movements. There are several ways to generate routes for SUMO. The first one is using the trip definition. As described in previous slide, each trip consists at least one starting and one ending edge and also the departure time. This is useful for when you want to create demand by hand or when writing your own scripts to import the custom data. You may either use DOA router to turn your trips into routes. Next, we can use flow definitions. This is mostly the same approach as using trip definitions, but you may join vehicles having the same departure and arrival edge using this method. Um, we can also use randomization for generating the demand. This is a quick way to get some traffic if you don't have access to any measurement, but be careful, the results are highly unrealistic. Um, we can use OD matrices. The origin and destination matrices are often available, from traffic authorities. They have to be converted to trips using the OD to trips program within the SUMO package. Um, well, next we can use the flow definitions and turning ratios. Um, you may also leave out the destination edges for flows and use turning ratios at junctions instead. You can use JTR router for doing this. We can use detector data or observation points. Mm, well, induction loops and similar devices are commonly used by authorities to measure traffic. Using the DF router program, you may use this data to generate demand. Um, you can, of course, generate route XML files by hand. Then we can use population statistics. The program activity gen, as I discussed before, can be used to turn population statistics into traffic demand. And finally, we can use data from other sources and convert them into SUMO format. Um, Actually depends on your available input data. You can decide which of these methods are more suitable. Okay, by now SUMO contains four applications for generating routes. Well, we've discussed these programs in previous videos, but for the sake of revision, let's recall these again. The first one is the DOA router, which is responsible for importing routes or their definitions from other simulation packages and for computing routes using the shortest path algorithm. Additionally, in combination with the simulation, the DOA router can compute the dynamic user assignment. Uh, Another option, JTR router, may be used if you want to model traffic statistically using flows and turning percentages at junctions. The third option, OD2 trips, helps you to convert origin and destination matrices into trips. And the final option, DF router, computes routes from a set of measurements collected from selected observation points. And finally, an option that does not generate the route file in itself, but can be used together with the DOA router is the program activity gen, which can be used to turn population statistics into a trip file and then using the DOA router generating a traffic demand. All right. It is also possible to define the demand file manually or to edit, generated files with a text editor. Before starting, it is important to know that a vehicle in SUMO consists of three parts: a vehicle type which describes the vehicle's physical property, a route that the vehicle shall take, and the vehicle itself. Both routes and vehicle types can be shared by several vehicles. It is not mandatory to define a vehicle type. I mean, if not given, a default type is used. The driver of a vehicle does not have to be modeled explicitly. For the simulation of, persons which walk around or ride in vehicles, additional definitions are necessary. As shown in route file A over here, we can define a vehicle with a route that belongs to it. By giving such a route definition to SUMO, it will build a red, vehicle of type, a red vehicle of, type 1 named 0, which departs, departs at time 0. Um, as you can see, the vehicle will drive along the big middle end and rend, edges, streets, and as soon as it has approached the edge rend, it will be removed from the simulation. Um, Actually, this vehicle has its own internal route, which is not, shared with other vehicles. It is also possible to define two vehicles using the same route. In this case, the route must be externalized, I mean defined before being referenced by the vehicles. Also, the route must be named by giving it an ID. The vehicles using the route, refer it using the route attribute. Uh, the complete change actually is shown in the route file B over here. Actually, here we define the vehicle type and the route, the vehicle type and the route externally, and then use them to generate two different vehicles. But before creating your own route, you should consider a couple of important things. First, routes have to be connected, which means routes should be created with consecutive edges. Second, routes have to contain at least one edge, and finally, route file has to be sorted by starting time. Here you can see an example of route file, which created using the vehicle type element. Um, this definition actually includes both the definition of vehicles, which the vehicles are purely physical parameters, which includes its length, its color, or maximum velocity, and also the used car following models parameter. Here, first the vehicle type is is defined, and then the vehicle itself, the vehicle type is defined externally, and then vehicle itself, defined to the network, which departs at time 0 with the type 1 vehicle, with the ID type 1. And also the root element here is the child element of vehicle, which is internally defined here, which includes the edge 1, 2, and 3. In addition, vehicles may be forced to stop for a defined time span or wait for persons by using the stop element, either as part of a route or a vehicle definition, as you can see from this example. By the way, stops, as I mentioned, can be child of vehicles, routes, persons, or containers. Uh, Here, the resulting vehicle will stop twice. Once at lane middle 0, uh, because of the stop defined in its route, and the second time, in the lane end 0, because of the stop defined in the vehicle itself. The first stop will last for 20 seconds, and the second one, lasts until the simulation reaches, second 15. Well, one of the popular ways of creating demand elements in SUMO is using the flow definitions. It is possible to define repeated vehicles emissions, flows, which have the same parameters as the vehicle or trip definition, except for the departure time. The vehicles are distributed either equally or randomly, in the given interval. For example, here we use the period to generate the vehicles. So flow can define their route, explicitly, like vehicles, or I mean, using the from, to, and via attributes like the trip definitions. Here, these are the examples of route file using flow definitions. There are, as you can see, three different ways of route definition within flow. In the first one, the route is defined as the child element of the flow, uh, as well as a stop, as you can see over here. The second example, the route definition is externalized, and then used in the flow. And in the third one, the route is defined, using within the flow, using the from and to attributes. And then a stop is defined within the flow. Okay, the demand information for the simulation may also take the form of origin and destination edges instead of a complete list of edges. In this case, the simulation performs fastest path routing based on the traffic conditions found in a network at the time of departure. Optionally, a list of intermediate edges can be specified via the edge attribute. Well, in this example, in the route file, we have one trip and two flow. The trip with IDT departs at time 0, and starts entering to the network from edge big, and remove from the simulation at edge end. Similarly, the flow with IDF begins at time 0 and ends at time 100. Please be advised that the difference between trip and flow is that in the flow we define a timestamp, but in the trip we don't. And we want 23 number of vehicles run through the network within this timestamp, which starts at edge big and ends at edge end. Well, now let's open the Netedit software and see how we can generate a demand file. All right. As we discussed before, there are three super modes: the network mode, the demand mode, and the data mode. We went through the network mode details in part 3 of this tutorial. Now, using the demand mode, we can create traffic elements like cars, bicycles, or pedestrians, and define their
travel route and travel behavior. Okay, the first mode of the demand super mode is the routes mode. The routes mode is used to define a travel path explicitly as a parent element and use in in vehicle definition, flow definition, or trip definition. Um, to create a route, you can either use one of these options, the non-consecutive edges and the consecutive edges. For example, in the second one, consecutive edges, you simply select the edges that you wish to pass your vehicle like this, and then click on finish route creation, and your route is created. Uh, you can also adjust other attributes like vehicle ID, like transportation mode, and some other elements that you can check it from the help section. The next mode is the vehicles mode, but before coming to vehicles mode, let's have a look at the types mode. The types mode is used to create and edit vehicle type and use them as a parent elements. These are some basic parameters regarding vehicles' physical attributes. You can specify, for example, vehicle class to be a passenger, pedestrian, bus, truck, or you can adjust the the vehicle lengths, the maximum speed, acceleration, deceleration, sort of things like that. Um, you can also have an access on more more detailed attributes using the attributes editor. As you can see here, we have attributes about vehicles car following model, lane changing model, and some other physical characteristics. uh, here the default vehicle type is the default V type. We also have another types, default vehicle types. Now let's create a new type with the name, for example, truck, and with the lengths a little bit longer than normal lengths. Okay. Well, now we should use those vehicle types and distribute them to network using vehicles mode. Uh, in the vehicles mode, we can create vehicles that pass through certain routes, like the route we created. Actually, there are several ways of distributing system which we should specify first. And for example, whether we want to generate the vehicles using the trip definition or vehicle definition or flow definition. Uh, the trip definition can be defined by simply by clicking on the first starting edge and the last ending edge with ID T0 and these default parameters, and after that click on finish route creation. As you can see, one vehicle with these default parameters is created within the network. Or you can use vehicles over route. In this case, the vehicles are assigned to a defined route. For example, here we can assign as many vehicles as we want with these default parameters to this route. For example, here I assigned 2 vehicles over this route. Or alternatively, you can assign a vehicle with with embedded route. The embedded route is defined by clicking over a list of edges in the network. um, let's suppose we want to create a route that passes from these edges, uh, like this, and then click on finish route creation. Here also Netedit automatically calculates the shortest minimum path. The next option is the flow option, which I think is the easiest and the best way to create the demand in the network. In this case, you can assign a flow of a flow of vehicles to a certain route with certain distribution. parameters. For example, here the distribution form is vehicle per hour. We also have another distributing forms, period and probability. That means in 3,600 seconds or 1 hour, 1,800 vehicles will be flowing, within the network. Well, to create a flow, simply click on origin and destination. Let me like this. This is the origin, and this is the destination, and then press on the enter key to finish the creation process. As you can see, now we have a flow which starts at this edge and end at this edge within 1 hour. Or you can also define the flow as the child element of a created route, using the flow over route. Well, here to create a flow, you simply click on a created route. Let's use this route, for example, but it's impossible. Okay, this route. Let's see. Yes, as you can see, a flow within this route is created. And alternatively, you can use the flow over embedded route, which similarly a flow can be assigned over over embedded routes. Okay, the next mode is the stops mode. Stop pauses a vehicle in a given position of the lane's stop. Actually, a stop can be defined either over a lane or over a stopping place like bus stop, container stop, or charging station, or even parking areas, and is always defined within a parent element. I mean, it can be the child element of a route or a vehicle. Here you can specify the the stop type. Let's choose the stop lane, and adjust some other useful attributes regarding the stop. I mean, the duration of the stop, the position at the lane, position of the stop at the lane, and then assign it to a route or to a vehicle. Let's assign a stop for this flow, for example, over here, with the duration 60 seconds. All right. And finally, we have the persons mode. The persons in Netedit represent pedestrians. We can generate either one person in the network or flow of persons. Each person needs a person plan, and this can be either a trip or a walk or a ride or even a stop. A person plan can start or end from from a bus stop or from an edge. Actually, I'm not gonna into more details, but I highly recommend you to learn the persons mode from the SUMO website. Now let's open the root file and take a look at it, in the text editor. Well, to save it, you may come to the demand element and save demand element as a root file with the rou.xml extension, and you simply open the root file in any text editor like Notepad. As you can see, we create a route with the ID R0 that passes these edges, and then create a flow, and then create a flow over a route with route ID R0, and generated some vehicles in route R0, and then put a stop on vehicle V1 on route R0 with the start position at 7.06 and the duration of 60 seconds, and then we created a vehicle over an embedded route. All right. Well, this is the end of the fourth video. You've learned the details of demand generation, how to create traffic demand within the network using the Netedit software. In the next video, you're going to learn the details of traffic light generation, how to create a traffic light within the network and adjust its signal planning, the phasings, and some other useful attributes. So see you in the next video.